Hi friends, welcome back. In this last lesson on the interest chapter, we are looking at certain questions which are correlated between simple and compound interests. And in this course, we have of course broken simple interest into a separate chapter and compound interest into a separate chapter. But these questions will lie somewhere in between because they use both of the concepts here. So the first question for you, which is the combination of simple and compound interest, is a question like this, which says that the compound interest on a sum of money is for 2 years is rupees 615, while the simple interest for the same period is rupees 600. So you are asked to find a principal, or you could also be asked to find the rate of interest. So let's focus first on the principal in this case. Now we have learned this in simple interest that every year the interest charged on a value is same, on the interest value, the interest annually for every year after year remains the same. And that's where you pick up this question from, that if we think of a principal as P and we think of the simple interest structure first, P is growing by 300, not the PCG, and 300 for 2 years, because if the simple interest for 2 years is 600, same period here means 2 years, that means the annual interest is 300. So what's happening in this case on the simple interest construct is the first year simple interest is 300 and the second year also the simple interest is 300. Now if you think of the compound interest part of the question says that in 2 years the compound interest was 615. The compound interest earned was 615. And we know that the compound interest in the first year is the same as the simple interest of the first year. So we know that P would be giving us an interest of 300 in the first year, even if it's compound interest, because the rate of interest is same and the principal is the same. So the compound interest will be same as the simple interest. And since the simple interest was 300, we can take the compound interest for the first year as 300. And because the total interest is 615 in 2 years, total compound interest is 615 in 2 years, what we realize then is that the second year's interest, the interest for the second year will be 315, because that's the only way to get 615 as total interest. And why is this different from the 300 you got? Because you're getting an interest on the interest. So what you can think of is, if you assume the rate of interest is X%, the way you can think about this is that X% of P is 300. That we know, we have used that for this, we have used that for this as well as this. But when you're doing this calculation, the 315 calculation, the value of 315 would have come from X% of P plus 300, which would be the same as X% of P plus X% of 300. Now we already know that X% of P is 300, and because the interest earned in the second year is 315, we can equate this to 315, and if I replace the first part of this addition as 300, I can see the second part of the addition coming out to be 15 to give me a total of 315. This is the only way this works, and that then gives me a realization that x% of 300 being 15, the value of x can only be 5%, because that's the only way 300 can give you 15 rupees as interest. So the rate of interest charged is 5%. So if the question was only asking you about the rate of interest charged, you have a solution to it. But since the question here has asked us the principal, we'll need to do one more step, and that step is that we know that x% of p is 300. Earlier we could not react to this because we did not know x and we did not know p. But now, as you can see, we now know x as 5%. So we can replace this thought by saying 5%, let me just clear the board, x% of p being 300, we now know that x is 5%. So 5% of p is 300. So naturally, this basically means that p must be 6,000, and you can think that either in multiple ways. You can think that 5% of p means 1 by 20 of p. If that is 300, p is 6,000. Or you can think of what value, if you take 5% of that, I should get 300. So you'll realize that 1% should be 60. If 5% is 300, 1% is 60. So if 1% of this number is 60, this number must be 6,000. You can do it through that, or you can do it through this 0.05 p is equal to 300, and p is 300 by 0.05, which means it is 6,000. So you can do it through any way. I think I would prefer you to do it through this, because it's completely oral that way. But anyway, with whichever way you use this solve this question, you can get the principal as 6,000, right? Then there could be another question which talks about the difference between simple and compound interest. So if I tell you that the difference between simple and compound interest, the difference between simple interest and compound interest of a certain sum of money for 2 years at 20% per annum rate of interest, whether it's compound or simple. So the difference between simple interest and compound interest of a sum of money for 2 years at 20% per annum is rupees 48. So what is the sum of money, or what is the principal that you have? Now again, this question has multiple ways of doing it. One way is that if you take x as the original amount on simple interest of 20%, you will get a simple interest of 0.2x and 0.2x, so it will become 1.4x here. And if you do it through compound interest, it will have a multiplier of 1.2 and a multiplier of 1.2, so it's going to become 1.44x in this context. And you realize then that 0.04x is 48. The difference between the simple interest and compound interest, the simple interest essentially here is 0.4x and the compound interest is 0.44x, because in both cases you started from x and the amount has the interest added in it. So whether you do a subtraction of this directly or by looking at the interest, you will get the same. 0.04x is equal to 48, and now when you solve for x, you will get x is equal to 48 by 0.04, and this is going to become equal to 1200 as the value of x. So that's one way of doing it. Another way of doing it is through the percentage structure that I showed you, the multiplier construct. If you assume the principal as 100, then in simple interest context, the principal will get added by, or the interest will get added as 20 per year. So after 2 years, your amount is 140, which means the interest earned is 40. And on compound interest, under the compound interest construct, there is a multiplication by 1.2 because there is a 20% per annum compound interest component. So there is a multiplication of 1.2, which means that there is a 20% growth 2 times. A 20% growth 2 times. So this will become 120 and this will become 144. And you can see that the interest earned here is 44 on 100, and the difference between the interest earned is 4, which is given to you as 48. So remember the multiplier logic we had talked about in the percentage construct. So if 4 is 48, the multiplier is 12. So on any of these numbers inside this box, if you multiply by 12, you will get the corresponding value in the actual terms. So since in this question the starting value is asked, the answer will be 1200, right? So that's how you do this question. Of course, there is a third way to do it. Although these two ways, I personally prefer this numerical way, the assumption way. X is not very quick to move on, and you always will have some writing to do in X. In this case, you can actually visualize this and visualize that. And hence, if they ask you for 3 years, all you have to do is plus 20 on the simple interest and a 20% increase on the compound interest, and you will get a value of 160 here and a 172.8 here. And as far as they give you a multiplier for this 12.8, you can again use that multiplier to get any value in this construct. So you can do this, you can use this method for 3 years difference between compound interest and simple interest over 3 years or 4 years or 5 years. But for simple interest constructs, simple interest, compound interest, different constructs, for 2 years, for the difference construct of 2 years between simple interest and compound interest, the difference can be also calculated by a formula which is PR by 100 whole square. This gives you the difference. This gives you the difference between SI and CI over 2 years for a principal P at a rate R. So in this question, the difference between SI and CI, which is 48, can be written as P into 20 by 100 whole square, which means that 48 is equal to P into 1 by 25, because 20 by 100 will be 1 by 5 whole square. So I can write that directly as 1 by 25. So the value of P is 25 into 48, which is 1200. So this is the third way to do this, but please remember, this only works for difference between CI and SI for 2 years. So don't try to use this for 3 or 4 years. For 3 or 4 years, you'll have to go. I think the best approach is the assumptions, by assuming the number in between to be the starting numbers to be 100 and so on, right? So that method try to use if you ask this question for 3 years, but for 2 years this is quite effective. So if the question is based on 2 years, you can do this, right? So I'll wind up now with this lesson, and this chapter closes. Make sure that you are able to execute all these constructs, and I don't think you should have any problem in any aptitude exam if you can think this way on interests. Bye bye. See you.